Okay, so we're going to work on the textbook problem. These ones on page 16. So you have to do my steps. The first step is to write the equation. The equation that we're talking about, let me see if I can zoom in. Okay, the equation is for kinetic energy. So kinetic energy is equal to 1/2 times the mass of the object times the speed of the object squared. Kinetic energy is measured in joules, J. Mass is measured in kilograms, and speed is meters per second, and that's going to be squared. I need you to see that these colors are units of measure. So a joule is equal to a kilogram meter squared per second squared. That's where I'm getting it from. So that's step 1. And step 2, I have to look at the book to see what our units or what our values are. In the book it tells us we're going to have a dog and we're going to have a boy. I have 3 variables. I have kinetic energy, mass, and speed. The kinetic energy is the unknown. That's the thing that we don't know. According to the text, the dog has a mass of 20 kilograms, and he's going to travel at a speed of 3 meters per second. Oops, forgot to color code. This is kilograms and 3 meters per second. So once I have my variables, I can then plug them into the equation, which is my step 3. Plug them in. So remember, the equation is 1/2 m speed squared. So kinetic energy, which is a joule, is equal to 1/2. The mass is 20 kilograms times 3 meters per second squared. So that square is going to go to everything inside of this equation. So that square is not times 2, that's times itself twice. So again, we have kinetic energy, which is measured in joules, is equal to 1/2 20 kilograms. Now we have 3 squared, or 9. I'm going to square my units. Meters squared per second squared. Now I'm going to take my 20 times my 9. So we have kinetic energy, which is in joules, is equal to 1/2 20 times 9 is 180. Bring our units back. Kilograms, meters squared per second squared. So I'm going to take the 1/2 times the 80. Is equal to 90 kilograms meters squared per second squared, or 90 joules, because energy should be written in a joule. So now we're going to do the boy. The boy, his kinetic energy we're looking for. The mass, we're going to make it bigger. It's 45 kilograms. The speed is going to be the same, of 3 meters per second. So we're going to plug them into the equation, the same equation. KE is equal to 1/2 mass speed squared. Kinetic energy is an energy, so it's measured in joules. Then we have the half times the 45 kilograms times the 3 meters per second, and that's squared. So this square is going to go to everything inside. So now we have kinetic energy, which again is in joules, is equal to 1/2 45 kilograms. And we're going to square this. It's going to be 9 meters squared per second squared. Okay. So now, according to the order of operations, we're going to do the inside. So we have, again, kinetic energy. Energy as a joule is equal to 1/2 405 kilograms meters squared per second squared. So now we can take the half of the 405, giving us kinetic energy. Again, that's in a joule, which is 202.5 kilogram meters squared per second squared, or 202.5 joules. So now I want to see the relationship between these. So the difference between the two masses, if you calculate the difference, is 2.25. So 45 is 2 1/4 times more massive than the dog at 20. So now let's look at our energies. We have 90 joules and 202.5 joules. If you take the difference between those two, it is also 2.25 times greater. So there's a relationship between the mass of the object and the energy of the object. As the mass goes up, the energy goes up at the same rate. So the mass was 2.25 times greater with the boy. The energy was 2.25 times greater with the boy. So now let's move on to see how the speed of the dog changes. So now in the book number 2, it says suggests that the dog now speeds up and goes at 6 meters per second. So I'm going to change this, is now going to be 6 meters per second. So I have my kinetic energy, which again is a joule, is equal to my 1/2. The mass is going to stay the same at 20 kilograms, but the speed is going to go to 6 meters per second. And remember that speed is squared. I'm going to square the 6, the m, and the s. Next line. We have the kinetic energy. Remember that's in a joule. That's the unit of energy. Is equal to 1/2 the 20 kilograms. And then we have 6 squared. So that's 36. And then square our units. Meters squared times, or divided by seconds squared. Okay, so now I'm going to go inside the parentheses. I'm going to do the 20 times the 36. So again, I have kinetic energy. Energy is measured in joules. I have 1/2. 20 times 36 is 720. Bring my units down. Okay, so I'm just keeping my units. Last one. Half of 720 is 360. Bring my units down. So it's 360 kilogram meters squared divided by second squared, or 360 joules. So now we want to see what is the relationship between the speed, so the speed and the energies. So when I double the speed, it was 2 times as great. The energies is 4 times as great. And that reason is because in the equation, the speed is squared. It's squared. So whenever I double the speed, 2 times 2 is 4, so that's why the speed is 4 times as great. Alright, I hope that helps. Bye-bye.